Hello, and welcome back to Backer Breaks It Down. We continue our lesson on chords and arcs. And while it may not seem like it, because clearly this particular foxtrot is a Star Wars reference, what we are seeing here is chords, arcs, and central angles. Okay, so like, what if those two pieces of bacon were congruent and the two pieces of toast, like the angles like they make with the center of the plate where the yolk of the egg is, if those angles were congruent as well and the chords were congruent, would the arcs also be congruent? Like, what do you think? So while some people might see Star Wars on that plate, I'm seeing congruent arcs, chords, and central angles. But, you know, I'm also a math person, so. But yeah, so there's a conjecture that says that congruent arcs have congruent chords, and congruent chords have congruent central angles, and congruent central angles have congruent arcs. Yeah. So in this diagram here, if arc BC is congruent to arc DE, then chord BC is congruent to chord DE, and angle BAC is congruent to angle DAE. Kind of neat, huh? But I believe in our investigation that we did a few days ago, we also discovered that. So let's apply this relationship. So in problem number 6, they want us to find y. So take a look at what we're working with here. Yeah, I mean, I see congruent chords in this diagram, and y is representing the measure of the arc. And so according to this little conjecture, those congruent chords means the arcs are also congruent. So that means this arc at the very bottom would also be y degrees, and the arc on the left would be y degrees. And so then notice that you know about all 4 arcs in the circle, right? Because you know one is 72, and the next one is y, and then there's another y, and then there's another y. So you've got these 3 y degree arcs plus that other arc that's 72 degrees, and you know, well, they all together will give you 360 degrees. So then we can do the math and we can determine what the measure of y is for each of those 3 congruent arcs, and we get that y is equal to 96 degrees. Okay, so let's check out problem number 7. We want to find z. All right, well, we're kind of dealing with the same stuff here. We are given, I see 2 congruent chords, so that means their corresponding arcs are congruent. So that means this arc over here would be 128 degrees as well. And so basically it's just like number 6, because I have 4 arcs, and all 4 arcs added together is going to be 360. So if I go 128 plus 128 plus 20, right, I'm going to get, well, let's see, should probably do that math right now, right? So 128, there's 2 of those, plus 20 is 276. And that gives us 360 when you add it to arc C. And then if we do some subtraction, we get that arc C is equal to 84. So this is like some pretty easy stuff so far, right? Like, where's the challenge? Just curious. Number 8, AB is the diameter. Find the measure of arc AC and the measure of angle B. Wow. Arc AC, well, that's really easy. It's equal to the measure of its central angle. So arc AC would also be 68 degrees. Then they want us to find angle B. Okay. So where do we go from here? It's like they told us that AB was a diameter. I can kind of see it's a diameter because it is like going through the center of the circle. So like clearly it's a diameter. And what do I know about these diameters? Well, what that means is that the semicircle here would be 180 degrees. And that little semicircle is made up of two arcs, arc AC, which is 68, and arc BC, which I can now calculate. I did that on purpose. And so if I go 180 minus 68, I get that arc BC is 112. So you know what that means. That means that the central angle is also 112. Granted, they want us to find the measure of angle B and not the measure of angle BOC. Okay, but think about it. It's been a while since we've encountered this particular situation, but remember, all radii of a circle are congruent. Okay. Now I want you to focus on this triangle right here. Let me color it in for us. Okay. What do we know about that triangle? Yeah, we know it's isosceles, and we have that theorem from last semester that says if you have a triangle with two congruent sides, then the angles opposite those sides are congruent as well. So what do we know? We know that angle B and angle C are congruent. So we can basically find angle B by using the fact that in a triangle, all three angles add up to be 180, so minus the angle that we know. We know that the measure of angle BOC is 112, so that gives us 68. And then if I divide this by 2, I'll get the measure of angle B, which is also the measure of angle C. But we only want angle B here, so angle B is 34 degrees. Now, I don't ask this question here, in the notes, but I want you to think about this question right now. We just determined that angle B is 34 degrees. Remember, this problem, the way it started is we basically knew that arc AC was 68. So do you see a connection between the 68 degree arc and the 34 degree angle? Any of you thinking it's half the arc? Yeah. Angle B is half the measure of arc AC. Don't go forgetting that because we'll see it, I believe, in the next lesson, but hey, right? I think there's something there. Anywho, if you didn't see that, that's okay. Like I said, it's coming up in a future lesson. All right, last problem, okay? Find x. Okay. So if you're thinking it's probably 16, okay, could you explain why you think that? Right? Because yeah, it is 16. And the reason why I know this is because over here, when I look over here at this segment, I see it's perpendicular to the arc. Not the arc, but the chord. So I know that the chord has been bisected. So that means both segments would be 8 centimeters, which means that the chord itself is 16. Okay, so I definitely know that chord on the right is 16. But how do I know that the chord on the left, the x, is also 16? Okay, well, if this angle here is 50, then the angle right next to it is 50, so the two of them together are 100, right? Which means these two angles are congruent. And when you have congruent central angles, you have congruent chords, which means x is 16, just like you thought it was, but now you know why it is. So yeah. But that's our like congruent arc, congruent chord, congruent central angle conjecture. So congruent arcs have congruent chords have congruent central angles, and congruent central angles have congruent arcs. And that's how Becker breaks it down.